For those of you learning how to write chemical equations, starting out with words and changing them into formulas, this video is for you. The diatomic gases are 7 elements that come up frequently in many chemical reactions. And we have to get used to seeing the name of these 7 elements and knowing how to write their formulas, and that's what we're going to cover in today's video. My name is Neil. I'm excited to help you with this topic. Take a moment and hit that like button, subscribe to the channel for more content, and let's get started. I hope you're ready to learn. So the diatomic gases are 7 nonmetal elements that we're going to have to remember because they come up so frequently in chemical reactions and therefore in writing chemical equations. Okay, what are they? Hydrogen, iodine, bromine, oxygen, nitrogen, chlorine, and fluorine. But how are we going to memorize these amongst all the other things we need to remember in chemistry class? Let's look at a simple mnemonic device to help you with this. Have you heard of Hebron Cliff? No? Okay, so how are you going to remember the 7 diatomic gases, memorize them amongst all the other stuff you have to know in order to understand and work with chemistry? I use Hebron Cliff. This is a way of just arranging the elemental symbols of the 7 diatomic gases to form a fictitious and highly memorable word. It doesn't actually mean anything, but it's great for committing it to memory. So remember Hebron Cliff for your next exam or quiz so as to not forget the diatomic gases. Now let's take a closer look at what makes them special in terms of their chemical formula. The name diatomic gases tells us everything we need to know about how we're going to represent these 7 elements when they come up in chemical reactions and equations. Di, as you know, is a prefix representing 2, and atomic means atoms. It turns out that these 7 gases on Earth at room temperature tend to occur with 2 of each atom bonded together. Now, of course, the word gases just tells us about their state of matter. So whenever we have a diatomic gas in a chemical reaction and we want to write it in a chemical equation, and we're just talking about that gas as an individual element reacting with something else, we always represent them in this way. Notice how after each chemical symbol, I have a subscript of 2. That's connected to the di. And of course, I have a lowercase g in parentheses telling me that they're occurring as a state of matter known as gas. Now again, we only represent them this way when they're individual. Of course, these can all be parts of compounds, well, and that changes everything. But the next time you see hydrogen or fluorine or chlorine as an individual element in a chemical equation, make sure you represent them this way. I think we should take a look at an example to clarify. Let's imagine we were tasked with writing a proper chemical equation for the following reaction. It reads, hydrogen gas reacts with oxygen gas, forming water. Okay, how do we translate that into proper symbols? Notice that it just says hydrogen gas. It's not called dihydrogen. There's nothing in the actual equation's words that tell us that there need to be 2 hydrogens bonded together. But because we've remembered our Hebron Cliff elements, we know that when hydrogen occurs alone on Earth in this atmosphere, it tends to pair up with another hydrogen atom. So I represent hydrogen gas as H2 with the G in parentheses. The same applies to oxygen. It's one of the Hebron Cliff elements, so I automatically know to write O2 with a small g for gas. Now, of course, on the other side of my equation, they're reacting and they're combining to form a compound known as H2O, or water. It's important to realize that just because I have O2 on this side, when oxygen is in a compound, that doesn't necessarily mean that it's also going to have 2 oxygens. The rule of diatomic gases only applies to the 7 elements when they're by themselves. Now, of course, this equation isn't finished. It probably noticed that it needs to be balanced, but that's a topic for another lesson. Okay, let's give you an opportunity to practice to see if you've caught on. Okay, try to represent the following reaction with a proper chemical equation. It goes like this. Hydrogen reacts with fluorine, producing hydrogen fluoride gas. Okay, take a moment, try to get those symbols correct, and come back to see what the correct answer to this question is. Okay, thanks for trying that problem. Hopefully your answer looks something like this. Of course, for both the hydrogen and fluorine as reactants, they're diatomic gases, so they're represented with the subscript of 2 and the G for gas. Now let's notice that in the problem, The word equation didn't actually say that hydrogen and fluorine were gases. It's assumed that we know that, so problems will not always tell you that they're gases. Just go ahead and represent them that way. Also notice that on the product side, just because we have subscripts of 2 over here, doesn't mean that they're diatomic as products. Once hydrogen and fluorine or any diatomic gases start to combine with other elements and make compounds, the whole subscript of 2 goes out the window. Now, of course, if you're looking at this and wondering why it's not balanced, that's a good catch. This requires a number 2 here. But if you're just here for diatomic gases and you're not ready for balancing equations, no worries about that whatsoever. If you've got questions or comments or just maybe some curiosities, I'd love to interact with you. I want to know what you're thinking about these topics and the videos in general. In any case, thanks for watching. I've got a lot more content coming to help you with your chemistry journey. Take care.